Hello everyone, it's Mr. G, and this is going to be lesson 6 of the Java Beginners tutorial. And in this lesson, we're going to be going over some basic error handling. What do I mean by error handling? So sometimes things can occur in the program, the code could be bad or input could be bad, and it can cause an error. Something that could cause the program to crash or behave in ways that are not intended. And it can lead, so basically we're talking about bugs. And this is not easy to avoid. But once you've done it enough times, there are certain things that you know to look out for and you just know to expect. So we can go back to our code from the last lesson, and there are plenty of ways that this could be wrong. Um, for one, the person could not enter an integer at all, and or they could input otherwise, like input that's not valid. And so I'll show you an example here. What if the person input -1? That would still run, and it still runs correctly, but there's no way a person could be -1 years old. Um, not in the traditional way that we think about things. So let's talk about ways that we can fix that. So we can use our if statements to kind of filter out some bad input here. So before we try to do any kind of operations on this age variable, let's check to see if the person is at least 1. So if age is less than 1, then we're going to do something else. And then otherwise, if age is at least 1, that's what this else is going to be. Then we can just kind of move this into there. Okay. And then here we can print out um, there is no way. We'll just type that. I don't know. I didn't think of anything better. All right. So if we run this and we run it like normal, let's say we put in 19, it still says that we're a legal adult because it, once we get that 19 and it goes into the age variable, it's going to check this here. And is 19 less than 1? No, that's false. So it completely skips this code. So it goes to this else block. Now, within this else block, we have another if statement essentially. So if age is less than 19, so age is 19. Is 19, or not less than, excuse me, is 19 greater than or equal to 18? Yes, it is. So this is true, and it'll execute this code, finish that out, and that's why we got the output that we got. Now, if we did 17, it's going to say we're still a minor for the same reason. We came here. Now 17 is not less than 1. So this is false. So again, it skips this code. It comes down to this if statement, and it prints out you are still a minor. This brings me to the next point about this. We have what we call nested statements. And nesting essentially putting in like one if statement inside of another. And you could do the same thing with loops and things of that nature. So we have this if statement buried in this if statement here, this one right here. So it's just a way to get more flexibility and power out of the Java language. And pretty much all programming languages allow for some kind of nesting, at least contemporarily. Um, so this is just a way that we can filter out some bad input. So if I put -7 here, it says there's no way, and we can actually be redirected here to enter the age again, but we'll learn that in a lesson further in the future. All right, so um, that's, I mean, yeah, so you can just use if statements to filter out bad input. Things that you can foresee being a problem, you basically program for that. And a lot of times, that's essentially what bugs are. They're just situations that can occur that the programmer didn't foresee. Um, you really have to make your programs dummy proof, and that's really hard to do. Um, there's a quote that I don't remember who said it. Those who try to make something foolproof underestimate fools, or something like that. We're humans, we make mistakes, and you might hit, instead of the enter key, you might hit, you might do something like this. Oh, how old am I? I'm 16. And then on the way to hitting the enter key, you hit this, and then we get that. And this is an error that crashes the program. As you can see, it's typing all this stuff out, and it's like, whoa, it's red and it's scary and all that. And we don't get our output here. We don't get this, this, or this because it crashed our program. This input crashed our program because it's looking for an integer. So, um, and we can't actually solve this type of error without proper error handling. So, this can be sufficient using if statements at times, but there's a better way to do it. So, I guess we can go over that now. I was going to put this in two separate lessons, but it's the same topic. So, let's cut this out. Let's actually no, let's keep that. So, when you think of this code, this line of code here, it's just like, oh, it's a line of code. But try to think of it as we're attempting to do something. We're attempting to get this input here and store it in a variable. That's like, so basically we want Java to try to do that. But we have to come up with, cases where it can't do that. It can't take this if it's 16 apostrophe. It can't store that into um, a variable that's an integer. And that's what this is telling me here. It says exception in the main thread, which is this, and this is the exception. So in Java, an exception is just an error. That's just what they call errors. So this is an input mismatch exception. Well, I mean, I think that kind of makes sense. It's not the right type. We're trying to put in, this would be a string, I suppose, and we're trying to put that into an integer variable. It's not going to work. So um, we have to find a way to avoid this crashing our program. All right. And this will actually tell you all the relevant stuff about it. This is the scanner object, and it's, showing different parts of this, for the code, the stuff that we imported. And then this is explaining where the error occurred in our program. So again, it brought us to line 10, which is this code here, which is what we already knew. We can't put something that's not an integer into an integer. Input mismatch. So the way that we would fix this is, knowing that that's an input mismatch exception, we would say, we're going to put the word try, and you notice that turned orange. And then we're going to have our block there. So this is where we're going to move that. All right. Now we have an error here because when we try something, we have to catch it. That's Java's way of saying, if this error does occur, what do I do? So again, it allows the program to behave autonomously on its own. We can have it make decisions, and we avoid the bugs and the crashes. So we have to put catch, and in the catch, we have our condition, which is not really so much of it's kind of a condition, but we just put in the error type. So we put input mismatch exception, and then we can put E here, and this E is just a variable essentially, and then we do our curly braces, and then we have to import this. So back to that import, we're importing this code. All right. Actually, let's go ahead and move all of this code up here. All right. And here is where we would put something, like we would just type something to them. So system.out.println, please enter valid input, uh, whole, wow, the spelling, numbers only. I think that gets the message across. All right, and let's run it. So how old are you? Um, H. Put the letter H and hit enter. And now, instead of crashing the program, we get this output. Please enter valid input. Whole numbers only. Well, that's exactly what we told it to do here. So what happened? Let's go back over it. We created our scanner object. We used the keyboard as the input. We also declared an integer variable and prompted the user for their age. Now, this is where things get a little more complicated, but we tackled the problem. Age, which is this variable we created up here, equals scanner.next. This is what we're going to try to do. We're going to try to do all of this. And if we can't, because the input is not the right type, then we just print uh, valid, we print this out, which, tells the person like what they did wrong. Now, with catch statements, oftentimes during debugging and during development, you would use this command as well. So this E here is a variable for the error that occurred essentially, and this could be whatever you want it to be, but E is standard, and you would type E dot, because remember E is an input mismatch exception. It's a variable. Print stack trace. And so what that would do is that, and I'm going to comment this out for now, just so you can see what I'm talking about. It basically prints out in red kind of what we did before, but it technically doesn't crash the program. So, um, you know, type that in for our age, and it types out the error for us. But the program did end, and we can see what the error is and how to fix it. So I'm going to take that out because when you handle errors properly, you don't want to see this. Obviously, you don't want the user to see that. You want them to be redirected in how they can fix the problem. And we'll see this come up more and more and more. Now, one thing that you can do is, what if there are different kinds of errors that can occur here? So, what if they don't enter anything at all but hit the enter key? We're going to have a different kind of error. So let's see what that is. Just hit enter and nothing happens. Now, that's not crashing the program, but it's not doing anything. So one of the biggest errors that you're going to see, and it doesn't necessarily apply in this case, it's called a null pointer exception, which is when you're trying to get the value of something, but it has no value. You're basically pointing to an object with no value or a variable with no value, and you're trying to use it to do something, and that doesn't work. So what we could do is put catch. We basically have another catch statement. Of course, we have to do our um, the error type here. This technically is not possible on an integer, and this variable has to be different than this E here. We have to do something else. So we could just say E1. And as you can see, we have a case there for it, and we'll just do e1.print stack trace. Again, it's impossible in this case, but in other cases it can be, because this age variable does exist, and you can't really get null pointers on integers, but this is just an example. So you can have multiple catches, and as you can see, this one try has 2 catches. And after that, we do have this keyword called finally, and what this will allow is for it to do something after, regardless. And so we can just type out um, thanks for uh, talking to me. All right, so let's run it. How old are you? Let's say K. All right, please enter valid input, whole numbers only, and then it thanks the user for talking to them. So that's what the finally does. Regardless of what happens here, whether it's an error that was caught or whether the program was able to do what was in the try block, it's gonna do that. So let's give valid input, and let's say the user is 9. Well, it says that you're still a minor, but it also thanks them for talking to them. Okay, that's what finally does. Regardless of what the outcome of this is, it does this. Okay, and it comes at the end. So not too bad, not too complicated, but now we're starting to see our program is starting to, for one, get bigger. You know, Eclipse is telling me I have 34 lines of code, 2 of those being imports, and we have a lot of different ifs and elses and trying and catching and all kinds of stuff. And we created this object here, and we have a full-fledged program that now that we have been able to kind of catch errors, it's a more robust program. There's no way that our program is going to crash based on bad input. You know, I can put, I mean, you can put any number, can you? So what if I put in 67.6? What do you think is going to happen? Pause the video and think about it, and when you're ready, unpause. So basically, let's run it. This input mismatch exception catches this bad input. It's still an input mismatch because we're trying to put in a double or a float here into an integer, and that doesn't work. So that's why it caught the that was here. It caught that error here, and it printed this out, and boom, it hit the finally block here, executed that code, and we exited our program. No crashes. So I think that's a pretty good way to get you guys started on, you know, getting user input and handling errors, because errors are going to come with users. Users are going to make, like I said, make mistakes. Sometimes they're, not thinking about what they're doing, and or they're just confused about what they're doing. Maybe the program isn't clear on what they're supposed to do. That's, on you as the programmer to steer them in the right direction and make sure they don't go off the rails. And then if they do go off the rails, you have to, take them and put them back in the right spot. Just like if you were playing Mario Kart and you fell off the track and a little cloud guy takes you and puts you back on there so you can keep racing, that's what you have to do as the programmer. And you have to foresee all of the cases in which something can go wrong, catch that error, and fix it. And a lot of times you won't foresee it. You'll just be testing it after you introduce new code, and you'll see, oh, I didn't even think about that. Or you'll have somebody else test it, and they'll, break it somehow. So you have to fix it. So this has been Mr. G, and I will see you guys next time.